Good evening, everyone. It's an absolute pleasure to see you here. My name's Associate Professor Susie Shee, and as a lot of you know, I recognise a lot of faces here. I've been the curator of the July lectures in physics for 5 or 6 years, something like that. This is our 57th year of the July lectures in physics. For those of you who are new to our series, it is, we believe, the longest running public lecture series, certainly in Melbourne, possibly in Australia. So it's really exciting this year that we've got such a diverse program of speakers. And my theme for this year, I called it Unravelling the Universe, from Ancient Skies to the Quantum Future, because I really wanted to cover the huge variety of topics that we're going to hear about over the next 5 weeks. We've snuck in an extra 5th lecture this year, which is technically in August, but we're counting it as July. So we're going to have topics from this evening's lecture on Pacific sky knowledge, through quantum biology, quantum computing, a very general lecture about our quantum century, and then a last little extra one about particle accelerators, because we're actually celebrating the 50th year of the Peloton accelerator, which is in the basement here. So we've got an amazing lineup over the next few weeks. Just a little bit of housekeeping that tonight, for the first time this year, we're actually live streaming the event, so hello to everyone who's joining us online. And that means at the end, when we have the Q&A, if you could wait for a microphone to come to you so that everyone in the theatre and online can hear your question, that would be fantastic. But I'm not actually going to be your host tonight. This evening, your host is going to be Associate Professor Dwayne Humaka, who is actually an Associate Professor of Cultural Astronomy here at the University of Melbourne. And I'm going to pass over to him to introduce our speaker for the evening. Thank you very much. Enjoy your night.
Thank you, Susie, and thanks everybody for coming out. It's going to be a really exciting evening. I'm really excited to be able to introduce our guest speaker. My name is Dwayne Humaka. As Susie said, I'm an associate professor here and director of the Cultural and Indigenous Astronomy program here at the University of Melbourne. Before I begin, I would like to recognize that we are meeting here on the lands of the Wurundjeri people of the Kulin Nation, whose connections to land, water, and sky run very deeply. And I'm very excited and honored to be able to say we're working on projects with both the Wurundjeri and the other Kulin Nation communities on their star knowledge. So there's going to be some exciting stuff coming out in the future with that. I would like to say that this is happening during a pretty exciting event here at the University of Melbourne. We're hosting an international school and conference this week and next week called Indigenous Astronomy in the Space Age. And we're bringing delegates from around the world with a focus on Indigenous communities and the Global South to come share, learn, and plan about astronomy and space activities both now and in the future. So I'm very happy and excited to be able to introduce Professor Clive Ruggles. Clive Ruggles, for those of us in our field, needs no introduction because he's pretty much the head honcho, one of the foundational members of archaeoastronomy and developing cultural astronomy on a global context. He's been very active for over 50 years. He's an emeritus professor at the University of Leicester, and he's going to be speaking to us tonight about another project he's been working on for nearly 20 years, I believe, on Pacific star knowledge, working with and collaborating with community elders in Hawaii and around the Pacific. So, Professor Ruggles, please come join us.
Thank you so much, Dwayne. It's brilliant to be back here, actually, in Victoria. I've been here twice before. The first time was dead on 30 years ago. And when I came here, I was taken out into the state by a very valued colleague, a guy called John, who, if you picture a sort of academic version of Crocodile Dundee, that was John. And he'd taken me to see some Aboriginal stone configurations, which I was privileged to do. John being John, we were camping. And me being the Brit, fresh to Australia, I'm worried about being in this tent, worried about things like brown snakes coming in and eating me in the middle of the night and this sort of thing. But anyway, I get to sleep. 3 o'clock in the morning, there's rattling on the tent. Clive, come and look at the emu. John, it's 3 o'clock in the morning. I don't want to come and look. Anyway, I eventually got out of the tent. What I saw that night was, I think, the darkest night sky I've ever seen in my life. I'm not just saying that because I'm back here in Victoria. I tell this story all the time. And the constellations you couldn't see. It was just, the sky was just lights, stars everywhere, a dome of stars. And the Milky Way was going right overhead that night. And you perceived it as being behind this curtain of stars. And against the Milky Way were some of the dark clouds, dark hydrogen clouds out there that form shadows against the Milky Way. And in those shadows was this emu stretching halfway up the sky. Its beak literally that high up, its body, and then its legs coming down to the horizon. You can't capture that very well in a picture. That's by far the best picture I know of it, and you won't get the best idea with the lights on. But and I think to myself, how can we in the Western world imagine constellations by joining the dots between the stars when this actual blooming great emu is there looming over us, this great shape? And it's that, and of course the emu was known as such to various Aboriginal communities. And you see it here in some of these pictures. This is a rock art depiction of that emu, and of course there are many other rock art emus around. And I suppose that's what draws me to my field, which is archaeoastronomy. Understanding other people's perceptions. We all see the similar sky, but we perceive it in different ways. So archaeoastronomy is what I do. You might like to know how I define it. You can see it in the dictionary, but that's how I like to define it. And the important bit of this for me is that last phrase, and the uses to which people's knowledge of the sky is put. Because archaeoastronomy is when it comes down to it, a cultural study. We're interested in communities in the past, and what we can tell about those, but from what we can tell about their astronomical knowledge, their perceptions of the skies. Why do it? Well, one kind of obvious reason is, well, all human societies, past and present, have a sky. And of course, in the modern day, we tend to forget just how spectacular that sky would be without all the light pollution we have these days. It was part of the world, the cosmos, that people found themselves in. All the landscape, all the things going on around them were all there for them to live within, but they also lived under this sky, which was so much an integral part of that, and they had to understand that and interact with it in different ways. Well, one obvious way in which people would have used their knowledge of the sky was in navigation. And that was one thing that first drew me to being interested in communities in the Pacific. Now, wind the clock back 50 years, and Western academics at the time a number of them were quite keen on the idea that the Pacific and all those scattered islands around the Pacific had been colonized accidentally, and that people had been forced out of overcrowded islands, got in the canoes, sailed off. Presumably most of them had perished in the process, but a few lucky ones had happened across other islands. The idea had been around since the 50s and 60s, but was gaining ground. And there were two things exactly 50 years ago that changed that and completely scotched that idea. One of them was the creation of the Polynesian Voyaging Society. It was a group of Indigenous Hawaiians working with other scholars. And what they did was to create a voyaging canoe in the traditional style. And this was known from historical accounts and things. A double canoe with crab claw sails and so on. They called it the Hokulea, which is the Hawaiian name for the star Arcturus, which goes overhead in Hawaii. And they sailed it using traditional navigation methods. Now, these weren't known anymore in Hawaii, but they found a Micronesian navigator, a guy called Maupila'o, who taught the Hawaiians how to sail by the stars and other navigation things. They also use ocean swells, other things like birds and clouds and so on, but particularly by the stars. Some modern astronomers helped to teach people about how the stars moved. And then the people sailed the Hokulea in 1975 all the way from Hawaii down to Tahiti. And that really proved for once and for all that was possible. The Hokulea has been going for the whole half century since then. They sail it around the world, spreading messages about traditional navigation. That was one thing. The other thing that happened back in 1975 was the publication of a rather unspectacular looking book. It's called Nā Inoa Hōkū, which in Hawaiian means star names, simply that. And it was written by two Indigenous Hawaiians. The lady here is Rubelite Kawena Johnson. We all know her as Ruby. She's basically a fantastic figure, well known within Hawaii. She's now in her 90s, but and these pictures were taken 10 years ago when they were signing off a second edition of the book. But back in 1975, she and this guy, John Mahelona, who was originally one of her students, I should say that Ruby spent many years sailing the Pacific herself and then settled into the University of Hawaii, became professor of Indigenous languages, or Pacific languages, because she was a linguist, as was John. And they wrote this book together, and the idea was that Ruby had been spending lots of time looking at archives in various of the museums in Honolulu, researching the original Hawaiian star and sky knowledge. And they wrote about this in the book together with some comparative catalogues of Polynesian, but wider Pacific star names. Ruby was very, very keen on this comparative analysis. And the navigators that took the Hokulea and eventually a couple of other canoes out used this book to reference the original star names. And those two events really turned things round, and exactly 50 years ago as it happened. And just to give you a couple of ideas about this, here's one very traditional technique, a very basic one, a navigation gourd. You hang a gourd, and you can, it swings around and it stays level, and you put a marker on one thing which marks where the pole star is to the north, and then depending which course you're trying to take, you mark that other course, and then you keep the pole star aligned and you sail off in the other direction. Another one I rather like, a concept, this comes from further south, from Micronesia, the stone canoe. This sounds a bit of an odd concept, really. What it is, it was discovered in the 1970s by an ethnographer working down at, who then was told this by some of the Micronesian navigators who still existed. But it was a technique. Basically, they put three stones on a beach, pointing in the direction of a distant island, an island in their group, maybe 3 days sail away. And the would-be navigator would just spend nights there watching the stars that rose or set, depending on the direction, in the direction, get to know them all. So that when they were out on the seas, they would be able to follow that course at night to the distant island. Now, techniques like that are good if you're going a couple of days sail to a nearby island just out of sight. But if you're on the open ocean, if you're out on the wide open Pacific and you're going to be sailing for weeks, you need a rather better method. And a fantastic method that was used throughout Micronesia and also in variants in other places was this thing called the star compass. And the idea there is and there were variants of this from different islands. So here am I on the ocean, and what I get to know is the rising positions of several bright stars and their setting positions, east, west. I'm in the tropics, so they're rising. These ones are rising more or less vertically. These ones are setting more or less vertically. And I may know about 30 of those positions around the horizon. If I'm in the northern hemisphere, I'll have the pole star I can see in the north, and the Southern Cross will be over in the south. At any particular time, of course, just a few of those stars will be near the horizon. So I'll see maybe 2 or 3 of my eastern stars over here, a couple of the western ones. And in my head, I can then basically imagine the ones in the gaps in between, and there's my star compass. And then as the hours go by, these ones rise, and new ones appear over here and fill some of the gaps, and these ones fall and disappear, and other ones. And I'm always going to have a few reference stars, and I can imagine the rest to fill in the whole compass. And of course, the latitude close to the equator doesn't make that much difference. It squidges them together a bit and widens them out a bit as you change latitude. But that is a broad compass. The actual stars used change from place to place. But things like that, techniques for using the stars, got people across the Pacific and to colonize some of the distant islands. Now, just to fill you back in when that happened, so the archaeology and other things tell us about this. So we know that around the 3rd millennium BC, people started to colonize through the Melanesian islands and fetched up in places like Samoa, Tonga, and Fiji around 500 BC. And that's evident archaeologically. There's a particular type of pottery, lapita ware, that's found here. We don't get pottery later because there was no clay on these islands, so people, when they got here, stopped making pots. And there's this period of about 1,500 years when we know people were then colonizing these islands around in the Central Pacific, what's now French Polynesia, and so on. And at the end of that, we're now in AD 1000 or so. That is when people who by this stage were distinctively Polynesian suddenly expanded out and over a period of just 2 or 3 centuries colonized Hawaii in the north, Rapa Nui, Easter Island over here, Aotearoa, New Zealand here, and other islands. And I like to put this thing up just to give you people an idea of the scale of the Polynesian Triangle as against places more familiar on the other side of the world. So that is well known archaeologically. And it's also supported linguistically. Now, you can find lots of things like the diagrams like this, and they're all complex, and they all vary in the detail. But the broad picture is that there is a language group. They're all related very broadly, the Austronesian languages. And people came out from maybe Taiwan or that sort of area, and these languages spread all around the Pacific. Not into Australia, although some of them partly affected the Torres Strait Islands here. But people come out into the center of what's now French Polynesia. The dates here, again, they vary depending on who you're reading. But then the Polynesian languages, which are a subset of the broader Austronesian languages, are what we find in the corners of the Polynesian Triangle. And there are bits here where you get a mixture. So archaeologically, linguistically, we know quite a lot about how people colonized the Pacific. And the other thing is, of course, what they took with them. And they took with them animals, pigs, dogs, chickens. Taro was one of the main staples. Other staples, coconuts, breadfruit, banana. And they also took sweet potatoes. Now hang on a minute. Sweet potatoes, they don't come from Southeast Asia, they come from South America. And there was this problem that people didn't like, people had surmised for some time before, particularly Norwegian explorer Thor Heyerdahl had surmised that people may have drifted across and arrived in Polynesia from the east. Now, all the archaeological evidence disproves that. But if you look at some of the sources in the 80s and 90s, there's almost a sort of apology, but how on earth did they get the sweet potato? And people speculate that maybe seeds or something, or tubers, could have somehow got themselves across 3,000 miles of ocean and landed up, and then people took them. We now know, of course, and logically, the solution to this is that, you think about the navigators who are discovering where there are islands, they're flying across the Pacific, and then when they find islands, then they go later with people and tubers and animals. Well, they're not going to know that, for example, that Rapa Nui is the most distant island. They're going to keep exploring. And so it's not really surprising that some of them would have reached South America. And in fact, in the last few years, DNA evidence has really supported that fact. So people did get across to South America, at least to the extent of getting sweet potatoes. And those sweet potatoes were part of what the Polynesians took around. So back to stars. Now, another thing we can do with the linguistics is look at the names of things. Now, the Pleiades, as I'm sure many of you know, have different names in Polynesia, Matariki in Aotearoa, But then you see all these dialectic differences around Polynesia. But it's essentially the same name, Makali'i in Hawaii or Mataliki in Futuna and so on. And what this is telling us is that the name extends back into what linguists construct as a sort of proto-language, which the term has been around for 1,000 years and was basically spread around Polynesian. So we know that that name for the Pleiades is at least 1,000 years old. And in fact, it's older than that. If you go back beyond Polynesia into Micronesia, you find rather similar names there. Makerica, Mairica, Mwerica. You can see the relationship, which is implying that that name for the Pleiades is very deeply embedded, perhaps 1,500, 2,000 years old in itself. And a few other things that sort of approach tells us, in particular, how something basic about calendars, because this is another way that, of course, people can use astronomy. What they view in the sky is in marking time and calendars. Now, if you look out at the skies before dawn, you're going to see stars rising before the sky gets too light. And the stars rise 4 minutes earlier every night. So there will come a time when a given star will appear for the first time before the sun in the dawn, and then subsequent nights it'll be a bit higher up. And that first appearance is called the heliacal rise. And that, we know, again from this sort of evidence, was something significant throughout Polynesia for dividing the year. In fact, there were two events that divided the year. The heliacal rise, which takes place in May or June, and this thing, the achronical rise, which is basically when the star is seen to rise at sunset. And those two events, and that one happens in November. And these divided the year, but it played out differently in the two hemispheres. So in the southern hemisphere, this was winter, and so for example, the Maori, the new year happened on the heliacal rise because that was in the winter time. And of course, that's now become a public holiday within New Zealand. And just in case any of you were falling asleep, I thought I'd put that one on just but it played out differently in the northern hemisphere. So in Hawaii, it was the achronical rise that started the year in November. And it was that event, it's called the Makahiki, the season that starts then, and that's just short for Makali'ihiki, which means Pleiades rising. And it's a period devoted to a certain god Lono. And some of you may know the story about Cook, when he first arrived, happened to arrive at that time of year and was taken to be the god Lono and revered in various ways, but it didn't play out well on a subsequent trip. Now, another thing about the Hawaiian calendar, and about the Polynesian calendar, is that aspects of that also spread out. So now it was a lunar calendar. The most obvious cycle in the sky is the phase cycle of the moon, isn't it? 29 days, 30 days, it's correlated with the female cycle. It's well known all over the world, many, many communities. This is the basic timekeeping calendar. And that was the case through Polynesia. And we can see various month names and various of these month names are found in different dialects, if I can say it, in other parts of Polynesia. But here, just to show you this, that these are just 4 of the different islands in the Hawaiian chain. And you can see that some of the names are the same, but they're coming in at different times of the year. And there are some odd ones that appear only in one of these columns. The broad way the calendar works, based on the lunar months, spread throughout Polynesia. But you see how it lives, it varies from place to place. They have a different calendar, a different variation, because that suits agriculture and other events that are happening in that place. So things like this, that in the detail, they are always living and changing. And you see that in some of the month names. Now, thinking about stars and calendars and things, well, how else do we tell the time of year? And one way is to look at the sun rising in different position up and down the horizon as the year goes on. And there are a couple of accounts known. There are a couple of instances where this happened within Polynesia. And this is on the easternmost point of the Hawaiian Islands here. And this one, there's the account that was recorded in the late 19th century, in fact. And it's about 4 lava pillars. And there's a place that people observed the sun rising up and down between these lava pillars. Now, if you went there, without that account, you couldn't know. These are natural lava pillars. And as it happens, we're on the Hawaii Island, the big island, which is volcanically active. It's actually fairly miraculous that those lava pillars haven't been overwhelmed by more lava. There have been a couple of flows since that have come very close, including one a decade ago. But we know from accounts that they were used in that way. And we know there's a similar account in an island right down in the southeast corner of Polynesia, Mangareva. And this was an account, again, it was actually recorded by a Belgian missionary, one of the earliest missionaries in that site, about how people use that mountain and also looked at the sun behind that mountain. And what's been remarkable in that case is that just a few years ago, 16 years ago, an archaeologist, Pat Kirch, and a local archaeologist actually were able to piece together the actual site of where the priest sat in pre-contact times to make those observations. And they did that by looking at where the sun was in the mountain fixing that up with the commentary. I have to say that another colleague of mine visited Mangareva 10 years later for different reasons and discovered the whole place had been bulldozed to build it, which was rather sad, but at least we have the record of it. So those are a few sort of background facts. So what can archaeoastronomy add to this? I mean, what do archaeoastronomers, people like me, tend to do? We tend to look at alignments, the Stonehenge and the solstice and that sort of thing. So how does anything that we can do add to all of what I've just said? Well, people have tried, and some of the earliest attempts were in the 1970s again. And one of the earliest attempts involves this. It's a rather amazing coral trilithon that's found on Tonga. And it looks for all the world like a bit of Stonehenge, doesn't it, out in Polynesia? Well, it was, we actually know when it was constructed, and we know that because there's an oral records that were handed down before writing came to the islands. And we know the name of the chief for whom that was constructed. And because of those oral records, we know the approximate date because we know the number of generations that went by. A New Zealand explorer, a guy called David Lewis, visited the island in the 70s and discovered not only that these were solstitially aligned, but there was an actual solstitial ceremony going on at the time. And he was very excited about this. And the island, and this got into the scientific journals at the time. And really, people were very excited. Well, since then, we actually now know even more. We know the very date when that festival, that solstitial festival, started. And the date is 1967, because as it happens, the king at the time, in 1967, got hold of a copy of a book called Stonehenge Decoded, which had been published a few years earlier, and thought, oh, I've got one of those, and it's fairly solstitially aligned, and started up his own ceremonial. So archaeoastronomy, if you like, in the Pacific didn't really start off too well. But one of the other things that archaeoastronomers have tried to do over the years is to look at groups of monuments to see, because the point is that anything that's oriented might be oriented on something astronomical, but that could be completely by chance. And if you've got a group of them doing similar things, that's good to look at. Now, all over Polynesia, particularly, there are temple sites. They're ubiquitous. They're called different things. They're the Marae in Aotearoa and other southern islands. You've got the Moai on there, Hōkūs on Easter Island, Rapa Nui. They're called heiau in the Hawaiian Islands, but there are lots of them around. And again, the first attempts to look at these didn't do very well. This is from a paper that was published in the 1990s about the Ahu on Easter Island. Now, you see, the thing about those is that most of these sites are around the edge, and they all point inland. Basically, we think they're probably they were sort of a form of protection, if you like. So there's nothing in those orientations, they're just pointing in from the sea. But what this guy tried to do was to look at the inland ones, a few of them. And you see, this is just a graph of all the different directions, the azimuths. And you see, they're kind of all over the place. And he tried to argue that, well, maybe there were 3 here rather than just 2 or 1. You know, that's not going to convince anyone, right? There's simply nothing in that. And that was all that was. Oh, and the other thing was that if we come to Hawaii, you've got accounts, again, from the oral history of how the temples ought to be built in certain areas. So in the ideal, in which way they face, where the male and female areas are, and so on. But then you look at the archaeology, and what you see is a much more messy picture. You know, they get elaborated, they get built in different directions, and things get added, and people build house sites onto the edge of them sometimes, because the temples were used for many different things. So it's kind of complicated. But into that, I mean, I went there trying to make something of this in the early 2000s. And after a couple of years of not very productive work, I came across this place. It's Kahiki Nui. And it's the south side of Maui, the island of Maui. And it's an area that's really very remote. It's quite marginal land, which is great because it means it hasn't become covered in golf courses and tourist resorts, but is basically largely as it was since before European contact times. That's where it is on the south coast, the southern side of the slopes of this mountain, the middle of Maui, Haleakala. And the thing about this area, there are various land divisions. The traditional land division in Hawaii was a narrow strip going all the way from the sea up into the mountains. And there are several of those. We have over 70 temple sites, well preserved, because when I got there, I discovered this guy, Pat Kirch from Berkeley, who'd been doing an archaeological landscape survey. There are plenty of other house sites, there are garden sites, all manner of stuff. Looks like an innocent landscape. It's actually horrendous. It's volcanic basically clinker, all different sizes, covered now in invasives like lantana, which is horribly prickly. And so it's very difficult to get through. It's a huge undertaking to survey it. But basically, we were able to survey these temple sites to look at the other thing, their orientations. And the other thing is that we were rather fortunate to have a very precise dating mechanism. You know how archaeologists use radiocarbon dating, and the half-life that we use there is 5,000 years, and radiocarbon dates, you tend to be plus or minus 200 or so. It happened that when people built temples, the tradition was to take a bit of coral out of the sea, just basically crack off a coral head, and put it into the wall of the temple to consecrate it. And that's great because it starts a radioactive clock, and it's a transition between an isotope of uranium and thorium, and has a half-life of just 50 years. And so we actually can date things with many of these sites to plus or minus 4 years, this sort of thing, which is brilliant. And what we know from that is this whole landscape was populated within a couple of generations, around 1600 AD. So quite late, and later than the people had first come to the islands 600 years earlier. And that's because it's a marginal landscape. People only started to spread into this area when the population pressures from the other areas forced them there. So a lot of surveying went on over over 2 or 3 years, scattered in years, over about 15 years in total. And if you just look at the orientations, we get something like this, and you can see they come into four groups. There's a group that are roughly pointing north. There's a group that are roughly pointing east. There's a group that are more particularly pointing east-northeast. And then there's a scatter, which are all actually blue. I'm not sure they look like it, but they are, which are anywhere around the horizon. And that's not something we'd be able to really interpret very well, but for the fact that we have ethnohistory. We have basically some of the Hawaiians that were still, that were remembered the old system just after the Europeans arrived and so on, and recorded what they knew of the old system. And from one of these, John Papa'i'i, we know that there were 4 principal gods in the Hawaiian pantheon. And you know, people tend to think of, oh yes, so Ku was the god of war, Lono was the god of agriculture, but it was more complicated than that. And they have all these different properties and things. And you see some of these, the east, the north, the sun, the sea. And you can perhaps begin where, you can see where I'm going with this. The north-facing ones are Ku temples, because Ku is associated with the north, also with the color red. And there are lots of lava, little lava outlets here, which are red, but you don't see it on that picture. The Kane ones, Kane is to do with the east and the sun. Those are the easterly facing ones, roughly towards sunrise. Kanaloa is the sea. Those are the coastal ones, which are scattered all around the horizon. And that leaves Lono, who is the god of agriculture and other things, which must explain the northeasterly ones. And they just seem to point to, if you look in the landscape, at some fairly arbitrary position just down the slope, looking generally to the east-northeast. But that point is where the Pleiades were rising. You remember the Pleiades associated with the calendar. That and Lono was associated with the calendar, agriculture, calendar. These sites are found at the top of planting areas, and they point at the rising position of the Pleiades. And when we look more closely at these, we found that some of them, 2 or 3 of them, actually have little sighting devices where the Pleiades could be sighted. If you're looking for the first appearance at dawn, you would know where to look. And there would be a priest stone inside these where the priest would lie and look at these, the Pleiades rising. Now, we can do more, we do more sophisticated analyses. We know about other Hawaiian stars. We found some correlation. So this is a graph as we do in archaeoastronomy, looking at probabilities of orientations. And some of them correlate. Just one thing I would draw your attention to here, because we have such precise dates, we can look at these stellar orientations, and they change over time because of precession, for the astronomers amongst you. And it just happens that at around 1800 AD, which is the latest dates we have of some of these sites, the June solstice sun, the furthest north the sun's ever coming up, is virtually exactly the same direction as the Pleiades. But because we can get the dates so finely, we can distinguish between those temples that are oriented on the Pleiades, and there's another form of temples that are oriented on the June solstice sun. But that's the sort of more detailed stuff that we can get into. One of the interesting things, as I said at the beginning, it's about cultural implications. And one of the things that interests us as archaeologists is the way that things developed from the time when people first arrived on the Hawaiian Islands around 1000 AD. They first settled on these 2 islands. Living was easy. You could grow taro easily and so on. And then gradually, as the population grows over the next couple of centuries, people start building fish ponds and terracing. And then they start moving on to the drier, more easterly islands, where you have to work harder, you have to be aware of the calendar and so on to plant, and you have to weed, you're aware of the weather. And it just happens that around 1600 AD, so now this is only a couple of hundred years before the Europeans arrive, we see the emergence of kingdoms in Hawaii, powerful kings who really ruled with an iron fist the people, and that rule was actually regulated by the calendar. So, for example, in each lunar month, so by the phases of the moon, there were certain days of the month which were kapu, taboo days, when there were certain things you couldn't do. The men would go to the temples. They would actually make tools and things, but they were confined to the temples. There were different rules for different days. If you broke a kapu, that was a capital offence. But this whole thing was to do with reinforcing the power of the kings that had come along by that time. And we can see how the calendar and those little temples are scattered around the landscape that were regulating that calendar, how they were part of that whole system that grew up. And so calendars were about power. And what we can see by looking at that sort of star knowledge, that how that was reinforcing the power in the islands. And anyone's interested in any more about that, there's a whole book that Pat and I wrote about that, came out a few years ago, all about the temples and what went on there. And just to finish this story, the Europeans arrive, and within 40 years of that, the whole kapu system was abolished, and in 1820 the first missionaries arrive and things were Christianized. But of course, indigenous practices remained. There were many efforts, particularly in the middle of the 20th century, to stop all that, prevent people even talking Hawaiian and everything. But things survived, and there are certain sites. I show you this particular temple site here, which is still sacred. There is knowledge about this. I'm not allowed to have the knowledge of exactly what goes on here, but we're allowed to know this is a navigation temple. And you can see there are many different types of stone here. That may mean something. But this was one instance in which the indigenous concerns about this coincided with astronomers' concerns, because there was a time, I think it was about 20 years ago now, when there was a threatened development in this area here, which would have introduced a lot of light pollution. And that was managed to be scotched, because this site is about the stars, and you need to see the stars from them. And of course, the astronomers were also concerned about what they could see from Mauna Kea. And everyone was going in the same direction about that. So we have star knowledge, practical things that seem to us practical, like navigation, calendars, all that seems fine. But there were actually a lot of other aspects which are to star knowledge and sky knowledge. And we can get at some of those by looking at some of the written accounts and some of the oral history. Now, there was no writing in Hawaii until Europeans came, but the oral histories were remembered in various ways. Things like genealogies, chants. This Kumalipo is a 2,000-line chant, basically. And it's a genealogy, because the Hawaiians love expressing things as genealogies. It was actually created probably in around the 18th century sometime for a particular chief. And what it was the genealogy starts with light and dark and starts to, as you go down the genealogy, you find all manner of information about trees and plants and stars, until you eventually come down to ancestors, and eventually real ancestors, people, and then down to the chief himself in this case. But that was remembered, and actually remembered exactly down various generations until it was eventually recorded after writing came. So we have things like that. We have informants, some of the early Hawaiians who saw the changes and wrote about how the system was before. And we also have early Hawaiian newspapers. So when they did get, the writing came in from the Westerners, the Hawaiians really embraced this. And within just the 1850s, within 30 years or so of the missionaries arriving, they started to produce broadsheet newspapers in Hawaiian, which went on until the end of the 1920s there. And you can see some of these contain gems of, this is part of a series about some of the star knowledge. You see right next to it is part of an equally long series about the Tarzan story. So there's all manner of mix in these things. But there's real gems in these newspapers. So when I arrived there in the early 2000s, I'd actually met Ruby Johnson a few years earlier. As Dwayne mentioned, we're having a conference next week, and it's actually the 13th in a series of conferences that have been going on around the world for 3 or 4 year intervals. And the first one was in 1981, and Ruby came to that over in Oxford in England. And that's where I'd met her. When I went there in 2001 for the first time, I met Ruby and John, so now I'm in the picture with the two of them, and worked with them to produce the second edition of Nā Inoa Hōkū. And I've now been working with them to produce a third one, which is just in press and will be coming out next year. And when I worked with John and Ruby on the second edition, what we were really keen on was to go back to these early Hawaiian sources and really understand them. The thing is, they were written in a way that you can only, because modern Hawaiian is written with various markup to distinguish long vowels, and they have a glottal stop consonant, you know, in words like i'i, you know. But people didn't realize in the early transcriptions they didn't need it in the Hawaiian newspapers because everyone was fluent. But to understand and interpret those now, you need people like Ruby or John who are fluent in order to understand them properly. So I worked with John a lot, and we produced new translations of sources. They're all in that edition. But what we've been doing more recently, and this is just with John, because Ruby's still with us, but sadly she's in her 90s now, and she's got dementia. So John and I have carried on this together. But we decided we wanted to carry on particularly the comparative stuff that Ruby was so keen on, Polynesian and Austronesian names for stars in particular. And so John and I worked extensively around Polynesia and Austronesia to produce a catalogue of star information and names. Now, this doesn't come without its problems, and just bear with me, I'll give you an idea of some of the problems. Oh, and that's why we were doing it. Okay, there's the obvious bits, first of all. So there are Hawaiian asterisms. Here's one of them. You might know it as Scorpius. So here's the constellation of Scorpius. But to Hawaiians, it's Maui's fishhook, the big fishhook of Maui. Maui, in Hawaiian legend, was a culture hero, a demigod, who fished up the Hawaiian Islands from the sea. And here is Maui's fishhook, to us Scorpius. And you see how the fishhook itself goes down into the Milky Way. So it really does, you can see why it's a fishhook, because it's actually down in the sea, the Milky Way, fishing up things. One of those early newspapers, an article in one of them in the 1860s, describes a school for training young navigators. And that's fascinating, but also introduces us to terms that were used by this particular school, and actually terms that we would use in modern positional astronomy, the celestial tropic of Cancer, that is, the celestial tropic of Capricorn, the celestial equator, and even the ecliptic, the path of the sun through the sky. And that is called the flaming road of the spider because the spider moves sideways and so on. Various things like that. So we know about things like that from some of these early accounts. But here's something. Some of the star knowledge was expressed in ways that seem very strange to us in the Western world. Here's another one from the 1860s. And this is a lot of star knowledge about months and their month names, star names. But you see now the months and certain months and stars are male. Others are female. And what's more, they're expressed as genealogy. So this star is the son of these two and so on, which seems very strange to us. But in the Hawaiian mindset, that makes perfect sense. It's a way to understand the relationship of all the stars. So the way that people are understanding stars is not our way, it's their way, and it's different. And in fact, this is a priestly, an account of a priesthood. Now, there were probably many different priesthoods at different times in ancient Hawaii, but this particular one was recorded, and it was recorded in umpteen weekly articles over a period of 18 months in one of the Hawaiian newspapers around 1900, 1901. And what this describes is a whole social hierarchy in the sky. You have chief stars, you have priest stars. Each chief has their priest. There are commoner stars, there are custodian stars that look after other stars, there are even god stars. And so suddenly you see people projecting their whole, their own social hierarchy into the sky. And their sky is populated by beings, be they chiefs or whatever, who can influence you, and you can influence them as well by certain things that you do. And of course, there's a temptation to want to identify all these stars and to come in as sort of with a Western astronomer mindset. And then you hit all manner of funny stuff in this. So for example, there's a couple of star names there, and the account describes how that star appeared on a certain night of the month in a certain month of the year. Well, you can get the certain month of the year, because that will be the heliacal rise. Certain night of the month, well, the moon phases shift around. That seems a bit odd in itself. And then you get that the star disappears in the next month. Well, hang on a minute, that doesn't actually happen, because if the star's heliacally rising, it's there for the next few months. You just see a different time. And what that's telling us is that, what people are perceiving there, a star is seen as that star with that name only for a limited period of time. Perhaps, quite likely, it's just when the star is just appearing before the sun, and a month later it's up there, but no one notices. It's not important anymore. They're interested only in naming these stars here. So a star name isn't for good. It's not like we would do it. It applies at certain times, and I think that sort of thing is important. The other thing is the problems. Now, I don't expect you to read this, so don't worry. But the Makali'i, I've told you that's the Pleiades. But actually, when you look at all the different sources that are out there, and you look at all the historical records, some of them native Hawaiians, some of them Western commentators, some of them ethnographers who spoke to Hawaiian, you suddenly see some people are saying the Makali is this star or that star or a planet or something like that. Only a few of them are talking about it being the Pleiades. Now, we have other evidence, as I already explained, about them being Pleiades all over Polynesia. But you see how confused this is. Now, maybe people are using that same name, Makali'i, for other stars at different times, different groups of people. This was not simple. It's not just the Hawaiians had an ancient name for this star. It's quite complex. And other problems we have. Now, there are non-Indigenous names. So, hang on a minute. Ubica? Venuca? Does that sound like a couple of planets to you? Could that be Jupiter and Venus? Well, yes, it could, because those names came in from some of the earliest missionaries. And in fact, Heliakala is a great one. Heliakala, Herschel, is actually Uranus. And of course, the Hawaiians didn't know about Uranus before the Europeans got there. But this is information that must have been fed in by the earliest missionaries in the 1820s and 1830s, and it comes out again. Here's another one, a bit more tricky, Hippocane, which is male sheep, which is Aries. Well, hang on a minute. Again, clearly the missionaries, one assumes, have told them that the Aries is a sheep, and that's become the Hawaiianized name. So there's this feedback. Is that a bad thing? Well, actually, these traditions of star knowledge and star names are always shifting and changing in the past. And of course, they continued to do this after European contact. So the Polynesian Voyaging Society has started to produce its own names to suggest new names for stars where the Hawaiian name, there's no Hawaiian name that is known. And so for the stars of Orion, they produce this name, which means the cat's cradle for the children. It's a string figure that children would use, and if you bend the string the right way, you get the stars of Orion. And this is the one I really like, Pu'uhonua. And this is for safe. It's the fourth of the dimmest of the four stars of Orion in the corners. And no Hawaiian name was known for that star. So they've given it the name Pu'uhonua, which is the name of a place of refuge on the west coast of Hawaii Island. Now, a place of refuge was somewhere where, an enclosure where a priest was. If someone had committed one of those capital crimes against the chief, then a place of if they could manage to get themselves to a place of refuge and inside it, then they could be pardoned by the priest. And so, of course, they'd get away with their lives. So places of refuge were important. So they called it after this place of refuge. Why? Well, because the Western name was safe, which is, of course, a Greek name, but it sounds like safe, hey, place of refuge. Imagine some poor etymologist of the future trying to untangle that lot. Anyway, and here's another thing. Now, and I'll stop after a couple of these, but just to show you how sort of problems we grapple with. I mean, Hōkū is a name that's applied to several stars, Aldebaran, Altair, Antares, in different accounts, and maybe in the planet Mars. Hōkū actually means red star. And so was that actually a proper name that they were using? Were they actually calling Arcturus? Or was it that some ethnographer would say, what's that star up there? Oh, that's a red star. Was it just a description? Was it not a name? All these confusions that come into this if you're trying to make something of this. And the last one, I promise there won't be any more of these. In the early inscriptions, when people were writing down, they didn't realize the significance of this glottal stop, so that makes it pa'a. As opposed to this long A, which is pa, and a pa'a means fixed, and a pa is a wall. Hōkū pa'a is the North Star, is Polaris, because it's fixed. And Hōkū pa is a wall star, so some formation of stars like that. Maybe it's Corona Borealis or something like that. But you will see in some of the accounts that Hōkū pa has become Polaris, clearly falsely. And there are all manner of other problems. People make copying mistakes and they get copied into modern dictionaries and so on. You can only untangle all that as best you can by going back to the earliest sources. So that's just the summary of everything I've been saying, but basically it's important, but it's not a fixed body. Don't think that there was a fixed body of astronomy knowledge, of sky knowledge before the Europeans arrived. It was always changing. It was different from place to place. And just to widen that out very briefly, a few more problems come in once we come out more broadly over Polynesia. So here's a whole load of names for a star. Here's just a generic name for star from different places. And here we've got the problem, well, how many of these are dialectic differences between different parts of Polynesia? And how many of these are simply because different ethnographers tried to copy a name as best they could when they heard it from an indigenous informant? Like Fetu here is written in a French way because it was a French ethnographer. And you get ethnographers coming in from the Netherlands, France, Germany, Britain, all struggling to understand the sounds they hear. So that's a big problem for us. But nonetheless, there are some rewards in that. So for example, we find canoe asterisms, not surprisingly, from different sets of stars around Polynesia. The Maori see Scorpius not as a fishhook, but as a broken, or this particular group of Maori do, but as a bird with a broken wing. And then in other parts of the world, people have speculated whether people perceive 6 or 7 Pleiades. Well, as we know from recent work by Maori scholars, particularly Rangi Matamua a few years ago, actually it's recorded that the Maori recognise 9 Pleiades. Now, how you distinguish some of these with the naked eye is intriguing, but they were looking at twinkling and other things which also had various prognostications about these gods, but there were 9 Pleiades for the Maori. Many interesting things like that. So what we've done in the latest edition of this book, which is coming out next year, we've actually produced what I think is considerably the longest, most detailed list of star names from all over Austronesia. So there's 3 catalogues: Hawaiian, broader Polynesian, and then the much broader Austronesian star names. There's about 2,500 stars in this, all with these sort of complex different meanings and so on. Just as a reference, we felt that this information is scattered in so many different sources, dictionaries, papers, articles, and so on, in many, many different places, that to bring it all together so that at least it was there as a source for anyone who's interested in taking all the study of this forward. And of course, that means we also produced a big reverse catalogues. So if you're interested in a particular star and what it was called around different parts of Polynesia or Micronesia or other parts of Austronesia, you've got a whole list of all the different names. And the IAU, the International Astronomical Union, has a star names working group whose job is to give internationally recognized names to stars. They've been working for about 10 years. Part of their remit is to try to, because most of the traditional star names in the sky are Arabic or Chinese or whatever. And the idea is to try and give a broad range of cultural names to stars in the sky. And so, so you can see some of the ones from Polynesia and Austronesia that have already been recognized internationally. Now, hang on a minute. You might see a little bit of a contradiction between me saying, well, actually, there was no one-to-one correlation in star names and trying to produce a catalogue. Well, I mean, the thing is that for the international community, this is a Western thing, if you like. The desire is to fix a name so that it can be recognized amongst Western academics, if you like, understanding that culture naming may move on. But there are, of course, deeper issues in this. And there's this well-meaning motivation, and that is to hopefully, by naming a star after using a particular culture's name, that you're going to respect that culture, and that's a good thing to do. But of course, you can see that might be interpreted as a rather a colonial thing to be doing. And so we have to be very sensitive about that, and where it's a living cultural name, make sure that this is done in a culturally sensitive way, and that the Indigenous people involved actually want this done, because in many cases they may not. So just to finish off, oh yes, I'm running to the end of my time here. Just, I showed you that at the beginning. I wanted to explain what that's all about. This wall that you're seeing here, it's a wall that is found, and it's been known right on the tip of the bottom of Kahiki Nui here, that I was talking about before. Very remote place now. You have to go 3 hours in a four-wheel drive to get there. And it's just an isolated bit of very solid wall. It's about 15 meters long, meter wide, this high, with this huge notch in the middle. But it was never connected to anything. And Pat, my archaeological colleague, was talking to an old priest about 20 years ago up on the island, and he for some reason just asked him, the guy, if he knew about what this was, because people have been puzzling about this. And he said, oh yeah, that's the Pānānā. Now, Pā means wall, as I already explained. Nānā is to look. So Pānānā means a sighting wall. And interestingly enough, Pānānā, as one word, is the modern Hawaiian word for a compass. Interesting. And when we looked into this, so then I got together with Pat and another colleague, and we did the archaeoastronomy, we measured it, discovered that it's not quite east-west, it's a few degrees off, and actually that means that it just aligns with the kite shape of the Southern Cross as it becomes vertical. We know the date. It had one of those coral bits. We know it was constructed in the 15th century. We also know that was the time that the last great navigators plied between Hawaii and Tahiti before the long-distance navigation finished. That is the name of the last navigator in oral history that went down to Tahiti and back. And Newe, the Southern Cross, symbolizes, for Hawaiians, it symbolizes voyaging to the south. And that and various other evidence, we reckon, was this wall, as we argue, was not some sort of observation device. It was a memorial wall. It was a memorial to voyaging. This is the point on the island when you come in, where you first hit the Hawaiian Islands naturally because of the way the winds and tides work. And we think it was a memorial to long-distance voyaging, perhaps to that last voyager. The work we did, the alignment on the Southern Cross, this was done with the stellarium system, which many of us use. And that photograph you see was actually taken after we'd published this by one of the Hawaiian navigators, Kalepa Baibayan, a few years later. So just to finish, well, why bother doing all this bit? I mean, it's interesting to people like me and so on. And I was giving a talk when we published the second edition of the book back in 2015 to a Hawaiian audience. And I was struggling to sort of try and say things like this, talking about the fact that, we have, raising awareness about the cultural achievements and so on, and respect for the cultural past and how we need to protect these things, all those sort of things. And then I was trying to say, well, there's this link between the historical and the living traditions, in that you want the historical stuff to inform the living tradition. I mean, the Polynesian Voyaging Society needed the basis of what we could tell from the past in order to keep the tradition going on. But in a sense, that also, the need for the living tradition gives the motive to look into the past. And I was trying to say this, and I was saying it as pretty much as a confused way as I'm saying it to you now. And at the end of the talk, one of the Indigenous Hawaiians came up to me from the audience. She said, "Oh yeah, we know all that. We've got a saying for that. It says it much more simply. It's this: Ikawama mua, kawama hope. From the way that goes behind comes the way that goes forward." And I think that sums up everything I'm doing and my interest. And thank you for listening.
Thank you so much, Clive. Really appreciate it. It was an amazing talk. We've run out of time, but we are going to, before we take off, actually, Clive, please. We've got a special gift for you.
Oh.
Prezzies all around.
Prezzies. I love prezzies. Thank you.
So we are going to be heading over for a reception at the Physics Museum in the building just behind us. So you go up the stairs. There's a ramp. You see the building next to us, go up to the top of the ramp and then take a right. For those of you who need lift access, go on the ground floor to the left. There's lifts in there. We'll have people at the doors who can help take you in. If you've got questions, burning questions, when we get over there, come and we'll try to not let you mob Clive too much. But come over and ask some questions.
Sure.
And if we've got any online questions, we'll see if we can address them at that point. So we're all good. All right, thank you very much.